Hello, I'm Dave Weidinger with the Missouri S&T Geotechnical Labs. Today we will be going over the laboratory procedures used for a standard Proctor compaction test. This short video will demonstrate how to conduct a standard Proctor compaction test in accordance with ASTM specifications. This test was developed to evaluate the level of compaction of field compacted soils. The soil is compacted into a mold at a specific energy comparable to the energy used in the field. The laboratory Proctor test is performed at varying moisture contents to establish a dry density versus moisture content plot. From this plot, the maximum dry unit weight and optimum moisture content can be determined. The practical application of this test in geotechnical engineering is for compacted specification of soils. The maximum dry unit weight obtained from this test can be used to determine the relative compaction of soils in the field. The equipment required for the standard Proctor compaction test is a 4-inch mold having a volume of 1/30th of a cubic foot and a collar, a standard Proctor compaction hammer weighing 5.5 pounds and dropping 12 inches, 2 moisture content cans, a steel straight edge, a large mixing pan, a graduating cylinder capable of holding up to 250 milliliters, a spray bottle, a metal spoon, and a knife. We will also be needing a digital balance, an oven for moisture content determination, and a sample extractor. The soil that we will be performing the standard Proctor compaction test on is a loess-seal silt obtained from the Mississippi River Valley. The soil has been mechanically pulverized, then air dried. The lab documents pertaining to today's lab can be found on Blackboard. The handout is posted there and is titled CE 215 Laboratory Number 5 Proctor Compaction Testing. In addition, an ASTM standard pertaining to this lab is also posted. ASTM D4698 pertains to Proctor compaction testing. Also available is today's data sheet. The Proctor compaction test consists of mixing soil with water to a predetermined moisture content. This soil-water mixture is then compacted into a mold of a specific volume with a standardized energy. At low moisture contents, interparticle friction will hinder compaction, resulting in a low unit weight. As moisture increases, the friction in between the particle reduces, and the particles will compact into a more dense pattern. At past a certain moisture content, known as the optimum moisture content, water will start to take the place of dry soil particles, and the dry unit weight will again go down. By conducting several standard Proctor tests at varying moisture contents, this curve can be established, and the maximum dry unit weight and corresponding moisture content can be determined. To perform the Proctor compaction test, start by weighing the empty Proctor mold without the collar. Record the empty weight on your data sheet. Also weigh the 2 moisture content cups and record their weights as well. With a caliper, record the dimensions of the mold so the volume can be calculated. Average 3 equally spaced diameter dimensions and 3 equally spaced height dimensions so that an accurate measurement of volume can be established. Weigh out approximately 2,000 grams of the provided air-dried soil. All right. Now that we have our soil weighed out, the desired amount of water to add to the soil must be determined. The weight of the water that needs to be added to our soil can be determined from this equation. The weight of the water equals the weight of the soil, 2,000 grams in this case, times the final moisture content minus the initial moisture content. The final moisture content is the target moisture content, which I have selected to be 15%. The initial moisture content is all the water that is trapped inside the air-dried soil. This has been predetermined to be 2.5%. With 2,000 grams of soil and an initial moisture content of 2.5%, and a target moisture content of 15%, it can be determined that I need to add 250 grams of water to my soil, or 250 milliliters. Obtain the correct amount of water from the tap and pour the water into the spray bottle. Using the spray bottle, add the water to the soil and start mixing it till it becomes a uniform color and consistency. When all the water is gone and the soil has been mixed to an even and uniform consistency, it is time to place the soil in the Proctor compaction mold. Start by placing the collar back on the Proctor mold. Spoon enough soil into the mold that when compacted, the soil mold will be filled approximately 1/3 of the height of the mold. Now you want to place the mold on a hard surface such as a concrete floor and compact with the Proctor hammer. Compact the soil using the standard Proctor hammer. Use 25 blows spaced evenly throughout the layer for proper compaction. After 25 blows, take the mold back to the table, scarify the surface, and add more soil for the next lift. Scarify the surface of the first compacted layer with a spoon. This will ensure that the second layer will bind to the first layer well. Spoon enough soil into the mold so that when compacted, approximately 2/3 of the height of the mold will be filled. Again, take the mold to the concrete floor and compact it with the standard Proctor hammer. The soil should fill the mold and extend past the top of the mold an 1/8 inch. Using the straight edge, trim smooth the top of the soil mold. Using the leftover material, fill any voids that might appear in the surface of the soil. Remove all the loose soil around the mold and weigh the mold without the collar. Loosen the soil mold from the base. With 2 hands, carry the soil in the mold into the extractor and extract the soil from the mold. Insert the soil and mold into the extruder. With 2 hands, carefully pick up the soil specimen and carry it into the other room. After the sample has been extruded, split the sample with your knife. Take samples from the top and the bottom and place them in the moisture cans for moisture content determination. Weigh the cans on the scale and record the weights. Place the cans in the oven. In 24 hours, remove the cans and record the dry weights. The dry unit weight of the compacted soil specimen and the moisture content can be calculated. From several iterations of this test, a plot of the dry unit weight versus moisture content can be determined. From this plot, the maximum dry unit weight and corresponding optimum moisture content can be determined.